Good morning, everybody, and thanks for joining us today. On this webinar, you've got myself, Andy Graham, and Phil James, the Availability and Industrial Computers Product Manager, taking you through a couple of different topics. So we're looking at implementing an efficient architecture with system platform as the initial focus. So what I mean by that is, if we just have a quick look at the agenda, we're going to start with a few of the latest features and benefits from a Wonderware perspective. I've literally just given a brief overview of these throughout this presentation, just to keep things fairly brief. What you'll notice, we talk about a lot of things and a lot of different capabilities of communicating to different devices with the Wonderware product set, but we don't really talk about how we make that efficient in an architecture. So that's exactly what Phil's going to do towards the end of this. So we talk about all these features, connecting our systems to our plant floor, and then all the way up to perhaps web systems, an enterprise layer for our management team. But we don't talk about how we actually do that and how we do it securely and efficiently. So one of the first features that I'd like to just mention, if you've not seen it already, is InTouch Web. So InTouch Web is part of the install with InTouch 2017 Update 1 and Update 2. I highly recommend Update 2 because they've added some additional support for more of the graphics in that release. So what this does is something slightly different to InTouch Access Anywhere, which is what you might be more familiar with. So InTouch Access Anywhere allows us to literally display our operator workstation in a web browser format, so we can render exactly what's happening on our operator screens up to whoever we'd like to see that data. We can do full control from there if we'd like to. It allows us to import and run .NET controls. We can literally have a fully fledged application at our fingertips. Part of the problems with this, though, not everybody wants full control, so they tend to go for read-only instead, which is obviously capable, it's possible, but then you still have that huge infrastructure cost, so you have to go server-based with InTouch Access Anywhere because it's using the capabilities of an RDS server to be able to deliver that content. With InTouch Web, it is a very small native web server that installs with the product, and it allows you to connect into your InTouch system and display some archives of graphics that you've chosen to publish. So it may be the same as the operator station ones. It won't be exactly the same screen layout. It won't look the same, so there are differences here. You can choose to publish just key KPIs if you'd like, or dashboards and things, and display them on big screens right on the factory floor. This is read-only full stop, so there isn't the capability to do read-write functionality. And the idea is that we can just get our information out to more people. So we could go all the way up to management with this, and they could have a very quick overview of what's going on the plant floor. You also get a single client included free of charge. So if you upgrade and migrated your InTouch system to this latest release, you would be able to use this out of the box. And then there's an additional cost if you want to go for unlimited clients on that single desktop InTouch. So it is just that desktop infrastructure required for this and not that big server infrastructure as well. Then if we just move into system platform, and you've probably heard us talk an awful lot about system platform in the past. This is, obviously for those of you that aren't aware, this is something that is, I suppose, more of an enterprise level SCADA. We're still very much as a Wonderware house hardware agnostic, so we communicate to anything, anywhere. This certainly extends our capabilities in terms of IoT because we can connect to things like these small sensor type devices and get data into a centralized SCADA solution and do whatever we want with that data. We also have a huge partner ecosystem which allows people to take the toolkits that you can use inside of the application and develop their own content and develop it so that it's really neatly aligned with the system platform portfolio. And there are some endorsed partners out there that allow you to get more solutions just by doing a simple bolt onto the package. It also integrates really simply with things like work orders from ERP systems, so you can bring those down to the plant floor and see exactly what's happening in your process. So it's really talking about the complete stack at this stage. One of the other things about Wonderware is they invest an awful lot of money on making sure that there is a migration path available. So if you've run in a system platform version, they make sure that you can upgrade to the latest version so you can take hold of those latest features. And it's no different than your InTouch systems or your Historian system. Wonderware pride themselves on making sure that's possible for you guys. I'm not touching on the actual latest visualization client, the InTouch All My Operations Management Interface. But what I would like to focus on is how they've made things a little bit simpler in terms of how you engineer the system platform environment, because I think there's been an awful lot of, I suppose, some complex talk around system platform. It's a more complex solution. The point of this is that it's actually just different. It's just different to standard SCADA. Different doesn't mean more complex. And actually, if you can understand the way that it works, then it can actually be much more efficient for you. And they're making that even easier with the advances in technology in terms of things like the auto build in our integration servers. So they brought out the Allen Bradley one quite some time ago now, and this communicates to the 5000 series controllers. They've also got, now very recently, they released a new Siemens driver that communicates to S7-1200 and 1500 PLCs. And what this does is allow you to essentially suck the values out of your PLC and import them into the system platform environment. So it'll do all that for you. So you can import thousands of references from your PLC straight into system platform and already have the correct structure built up, providing you're using things like UDTs in those PLCs. So our UDTs allow us to define a similar structure to what we'd normally expect inside a system platform. System platform's all template-based anyway, so it matches up nicely. And we tend to say that the objects that you create inside of it should be based around things like assets and units. So it's very, very similar in that regard. So when you suck in the data, it'll create a number of instances for the number of assets based on the PLC items that you're importing, and create all those objects for you in the right manner. Now, one of the advances of Update 2 for System Platform 2017 is that they've introduced object alias names. So obviously when you're pulling in items from PLCs, they can obviously, or they might not have friendly naming conventions, so it's something that not everybody would understand. The purpose of this alias naming is that actually now we can change it to something that everybody does understand. So that is one way to get everything into system platform, and then you've got to do things like associate graphics with those templates, and then present them in your visualization client in some way. The next thing that they've done, and this was released in 2017, is something called Object Wizards. Now, if we take an example here of valves and going back through how system platform was engineered, some people did actually try to create these super objects, if you like. So they'd include everything associated with every variation of the valve that you have around your plant inside of a simple template. And then when you instantiate that then means that you're instantiating everything to do with all of those valves. So if you wanted only a two-way valve, you're actually using the resources that it would take for a four-way valve. But not only that, you're getting a load of error messages because you've got item names that aren't linked up to the template, and that is creating a serious overhead for the system, and it's unnecessary. What they do with Object Wizards is that you can now set up a set of options, if you like, and then when you instantiate it, you instantiate only the details that you need, very simply. The system does it for you after it's been engineered. And what this also means is that they're providing object libraries out of the box. So they've provided the first one, and they're expecting to do more based on different verticals and things as we go through the years. But this has been taken from the orchestra symbols, the situational awareness library that has been around for quite a few years now. And they've taken the most common assets that you tend to use around your plant so you can reduce your engineering time. So things like equipment, meters, valves, these are all assets that they've taken and create these object wizards for, so that when you want to go and instantiate them, you can do that very simply. And you can do it with all the graphics that are associated with it, because all the situational awareness graphics live inside of these objects. There's also in terms of dashboards, you have all those available to you, and even the faceplates associated. And when you look at that and you marry that up with the latest visualization client, the InTouch Operations Management Interface, we can actually start to build applications that build and navigate through automatically without actually having to do too much engineering to be able to achieve that. And when it talks about the variances of being able to deliver what you want to deliver, these are all the things on the screen that you have available to you. And they've introduced wizards inside of this, so you essentially choose the graphic that you'd like from the object wizards that exist. You drop that graphic onto a Orchestra graphic pane, if you like, with the editor wizard, and it will show up with a wizard that starts to ask you questions about how you'd like that graphic and the object to look and feel. So would you like alarm limits associated with it? Yes or no? It then builds all that dynamically for you in the background. How would you like it to be oriented? Would you like it vertically or horizontally? And there's actually over 1 million unique combinations that are possible with this, but it's done in a very simple way from your perspective, from that user interface, because it's just asking you very simple questions that we all understand. Now, when you've done this, the next key is how we assign the I/O to those objects. So yes, we've got loads of instances we want to communicate to our PLC items. We couldn't suck the data in through our integration server because that would have created the objects for us, and we wanted to do that creation of those objects through the object wizards. So if we take the same methodology in terms of how we look at the PLCs, and we've got UDTs here, so we're engineering our PLC with UDTs. It's the same structure that we actually want inside of System Platform, as I mentioned earlier. So if we match that using the objects that we're creating from the object wizards, we then have an ability to do something called I/O auto-assignment. So what this allows us to do is drag the objects that we've created into the topics that are linking to the PLC, and providing that those structures align, the structure inside the System Platform and the UDT structure in the PLC, they will automatically link all of the I/O for you. And you can even test that they're working in design time. So you validate them here. You can even update the resulting reference if it isn't quite right. So you can do like a bulk export and import to achieve that. So they're simplifying the way that we can get the data into the system. Then lastly, I just wanted to cover a little bit about, I suppose, the portfolio as a whole, looking at the different products in the stack, and then a bit about the value of Orchestra Graphics, just because we mentioned Orchestra Graphics for a long time, and we do it every single presentation. We've been doing it for probably the last 8 years since they were first introduced. And I just wanted to show you how important they are to be getting on board with and the reasons why. But firstly, I suppose, really, if we look at the scale, at the top end there, we're looking at like SCADA, and towards the bottom end, we're looking at HMIs and down to device layer at the bottom level. We do take some system platform installations, and as you can see, it's more of an enterprise type solution, which tends to gear up to larger installations, but there are some very cost-effective starter packs that you can introduce to that lower market, and we have done that on numerous occasions. InTouch also works its way up, so we have standalone InTouch, standard edition InTouch, up in control rooms and things. It does provide a great and easy to use interface to be able to deliver that. And if we look at how the Orchestra graphic environment sits, we're actually talking about a single editor here for every environment. So we're using the same content, we create it in one, we can reuse it across the stack. From a web browser perspective, we mentioned a couple of them today. It uses the same web browsers across the stack. So it's InTouch Access Anywhere or it's InTouch Web. They all use the same functionality. And the difference here is that when we get to the next generation, the new operations management interface, they've started to adopt these Orchestra graphics, but be able to provide them in real context to applications, as they're calling them. So being able to deliver more with the same content. And then if we look into the future a little bit more, we can see at that bottom layer, that machine edition layer, the other software package that we have, they're actually looking to implement the same editing environment so that you can use and get the same look and feel of these orchestra graphics throughout your entire system. So you design once and you reuse everywhere, which is a huge plus point for it. So with that, you have heard me talk an awful lot about communicating to PLCs, even getting up to management layer in terms of web browsers to be able to display your information to the right people at the right time. So what I'm going to do now is hand over to Phil, who's going to take you through how you design that efficient architecture, how you introduce some types of security, because it's really important that we're not just putting in technology, we're actually securing that infrastructure and making it efficient. So I'll hand over to Phil.
Hi everybody, thanks Andy for that introduction. It was so good, I'm just going to jump straight into this. So yeah, when we speak to our customers about cyber security and making architectures inherently more secure, they tell us that there's a lot of advice out there. So there's lots of directives and bits of information from different departments and what have you. So because it is a little bit confusing about where to start, and it is such a an important and topical subject matter, we thought we'd elaborate on that as part of the webinar this morning. So I mean, the crux of it comes down to we need to make sure that you've got the right actions for people, so the right behaviours, the right processes in place, and the right technology that you're adopting as part of this more secure architecture. So what we'll do as part of the webinar is mainly focus on the technology aspects. So even though there is a lot of information, what we found really helps is the 7 pillars of best practice from ICS. So you can see the 7 pillars there. So what I'll do during the webinar is talk through each of those pillars in turn. But what the ICS have allowed us to do here is to sort of apply a staged approach to cybersecurity. So what I mean by that is, if you look here on the far left-hand side, what we find that is really useful for people is to first let's audit what we have. Let's see the lay of the land. Let's assess it. What's working, what's not working. So by using a networking audit, it allows us to really look at what we're trying to protect and what assets do we have. So what it will do first and foremost is obviously give you that lay of the land, as I say, but it will also give you the opportunity to address some low-hanging fruit. So that could be things like passwords that need changing. It could be badly configured firewalls, conflicting IP addresses, that kind of thing. And once you've done that, then it will allow you to fix some major security holes, optimize the network, and then you can start to look at managing it going forward. So like I say, adopting these networking standards, so people, technology, processes, behaviors, that kind of thing. And then it allows you to design in, inherently more secure processes and policies and that kind of stuff. So if we look at the first pillar, which is application whitelisting, I heard a cybersecurity expert talking recently, and he used an analogy for explaining the difference between blacklisting and whitelisting. So I'm going to pinch it. So what it was imagine you're taking a small child around a supermarket. He's pretty naughty, this child. So one of the things that you say to him is, whatever you do, when we go to the drink section, don't take out a bottle of milk and throw it all over the floor. It's not allowed. So you start walking around the store, and the first thing he does is he doesn't touch the milk, but he gets some orange juice, takes it, gives it a shake, chucks it all over the floor, big mess. But he hasn't really broken the rules that you've given to him there, because what you've done is you've essentially created a blacklist. You've told him the things that he's not allowed to do. So a different way to approach it is to look at a whitelisting approach. So what you could have said to the boy before you entered the store is, right, all you're allowed to do is to hold my hand and walk sort of patiently by my side. And that way he knows the rules and he can't deviate away from those which is what we call whitelisting. So application whitelisting is exactly that. So it's a practice of specifying an index of approved software applications that live on a computer system or a server. So it's different to blacklisting. There are applications that help you to achieve this kind of methodology. But what we find works really well, and I'll talk about it more as this webinar moves on, because it does address some of the other points of the 7 pillars, is Theme Manager. So if you don't know what it is, Theme Manager is essentially it's a content broker for an RDS system. So what it allows you to do is to deliver the content or the applications that you have, and sort of divvy them up into 3 ways. So you can deliver by device, so you've got a device on the Plant 4 network and it's going to have an InTouch application, let's say. You deliver that application to that device. You could then do it by user, so you could say, this guy's a supervisor and he's allowed a different set of applications. I'm going to deliver them to the user regardless of what device he's on. Or you can do it to location, so an application that lives in the Plant 4, stays on the Plant 4, doesn't go anywhere else. So that is a way of securely delivering content, and by using RDS, it means that you haven't got those applications living on thick clients dotted all around the Plant 4. You've got them on nicely protected servers with only the people allowed to access them being able to do so. So then if we work on to patch and configuration management, so if we stay with a Theme Manager theme and we look at a traditional automation network, you can see it there. We've got a control room, a Plant 4, some Plant 4 offices. Every single one of those stations has got a display, keyboard and mouse, and a PC. So on those PCs, what have we got? We've got an operating system that needs to be at the right sort of patch level, the right version. So that lives on there. We've also got your applications, so each one might have an InTouch application on there. You might want one to be at version 10.1, you might want some at 2014 R2, 2017, whatever it is. So they need to be at the right version. You've also got your antivirus that lives on there too. All of these devices have moving parts, so they're more susceptible to failures, to something that's more solid state and fanless. And they've all got USB access, so if somebody plugs a USB stick in there, potentially they're going to be able to copy over that potentially nasty data. So guess what, we've got loads of these devices, so we've got to manage a lot of stuff. So if we flip that and look at it in a Theme Manager environment, what we're first going to do is we're going to introduce a server room. So we've got a pair of terminal servers in here. So the first thing we do is we take all of those bits of work, those things that need to be patched and managed, take them away, and we put them on the RDS servers in the server room. So now straight away you can see that we've only got one set of operating systems to manage, one set of applications to manage, one set of antivirus to manage, and all of those single instances have now been removed. You can also see that the thick clients have been replaced by thin clients, so more secure. I'll touch on that later on. What this picture doesn't show is every instance here has got a keyboard and mouse, so it could be that those ones in the control room, that might be one operator, and he might make it easy for him if he's got a shared keyboard and mouse between those two displays. So with Theme Manager, you can do that. So we put Theme Manager on the terminal servers, and then we can propagate through whichever applications we want to be delivered to those devices or to those users or to those areas. So much more easier to manage and maintain. So just to illustrate that further, here we've got 8 devices, 8 thick clients in a traditional setting. You've got to go to each one of those terminals, you've got to visit each station and apply those patches and those configurations. With Theme Manager, okay, you're introducing a new device, you're introducing a terminal server, but guess what? We put Theme Manager on there, and that's going to take care of it for us. We do it once, and it will be propagated throughout the system. So next, if we look at minimising attack surface area, pretty much leads on to what we've just been talking about. So if we take a SCADA network, so you've got your field devices, your sensors, your I/O points in the bottom layer, and then we've got the PLCs and controllers sat above there with the thin clients and the I/O or tag servers sat on top of there. So what we can do, if we do use the thin manager approach, we can use what's called a zero client. So if you imagine operating an RDS architecture without thin manager, chances are you're going to be able to make use of thin clients, yes, but you're going to still need likely some sort of operating system. So it's probably a lightweight thing like a Windows embedded or lightweight Linux OS, and that'll be there to manage the connection. If you've got an operating system on there, you're going to need some sort of storage living on the device as well. So it might be, a little flash drive or something, rather than a fully fledged 500 gig hard drive or something like that. But you've still got storage there. So with Thin Manager, it allows us to get rid of that. It's what we call a zero client. So they're all solid state anyway. So they're all fanless, no moving parts. But because there's no storage on there, there's nothing that locally resides on that client. It means that there's no IP stored on there. Essentially, if you take this thin client outside of your network infrastructure, it becomes a metal brick. So it's completely useless to anybody. So inherently more secure, nothing can be stolen. The USB ports on a zero thin client from Thin Manager, they're all locked down. They're all, by default, you can't use them. So unless you go and turn them on, somebody who plugs these USB sticks into, they found one in a car park or something, having a bit of a nosy to see what's on it, they're not going to be able to do that with Thin Manager out of the box. So yeah, more secure. In terms of the actual thin clients, you can see a broad selection of them there. Most of them are the metal brick types that I've just mentioned. In the bottom right hand corner there, you've got the Dell and HP, those type of guys. They make thin clients too. You can use those with Thin Manager. It's absolutely fine. In the middle, you've got a panel PC. So what some people like to have is that because they don't want to do fault finding between failure of the client or the display, if you use them both stuck together, both the same unit, it doesn't matter if somebody's put a screwdriver through the screen or there's been a processor failure on the board of the thin client, the operator just changes one out and replaces it with another. So very, very easy to replace as well, the thin clients within Manager. Probably 2-3 minutes, something like that, to get them swapped over. So very easy to manage and very, very secure. So if we're talking about minimizing the surface area of attack, but now we've introduced a terminal server, because all of your processing is now centralized in one place, we need that central location to be protected. So Stratus offer a fault-tolerant server, an FT server, and you can see the picture there. Essentially, it just looks like two servers that have been strapped together. What's unique about the Stratus FT server is it has proprietary software and hardware that allows the two slices to be lockstep together, so they work in tandem with each other. So any compute or calculation that's running on the top slice is running at exactly the same time on that bottom slice. So it means that you can suffer multiple failures across slices, and it'll just power through, it'll just continue to run without suffering downtime. So it also is part of an active service architecture. So if the top slice, for instance, goes down, it will automatically, it's clever enough to dial home, so it'll talk to the Stratus support desk, it'll say, I've got a problem, and the next business day they will have a replacement slice out with you. Because they are hot swappable units, this new slice will turn up, and it's just a couple of thumb screws to replace it. So you don't really need a skilled IT person to be able to swap these over. Pull one out, put the other one in, and the system will automatically bring itself up to speed without any degradation of performance. If you were to open these things up, they're just a standard x86 architecture. Same industry-leading Intel chipsets that you'd expect to see in the leading consumer-grade, office-grade server. So for IT personnel, there's nothing alien in there. They're just very, very intelligent machines. So if we look at the options of putting in terminal servers and what's available to you. If you look at the left-hand side, that's a standard server, so a standalone machine, might be a Dell or an HP or something. So you could pick the top spec you could imagine, but it's still a single point of failure. So if something goes wrong, you're suffering downtime from minute one. They'll normally have a service contract or something with them, or the break-fix model will normally take around 1 to 4 hours, something like that, with the so whilst that machine is down, you're suffering downtime. If these are in remote locations, it's even more difficult to manage. So they're about 99% available. So then if we move across to the right-hand side, we've then got a cluster environment, which are very, very popular, particularly with IT professionals. They know them very well. So what we're going to do is introduce another one of these servers. They've got a heartbeat between them, so they know where they're up to. But you need to introduce more hardware. You need to introduce at least 2 networking devices, some sort of shared storage, so SAN or something like that. And then you need to make sure that your applications, which you may need more because you've got more servers, so you might need multiple copies, you need to make sure that they're cluster aware. You've got some scripts to facilitate the failover. And if one of these servers go down, it's going to fail over, albeit very, very quickly, but it will fail over. So if something isn't committed to disk at the time of that failover, potentially you've lost it. It's corrupted, something like that. So if we move across to the right, you've got exactly the same way of doing it, but in a virtualized way. So using something like VMware HA, something like that. So you don't now need to make your you don't need some failover scripts to instigate that failover if one machine goes down, but you still need that same infrastructure, so the same number of network devices and SANs. You need somebody to be able to manage these as well, because it's a complex architecture. You need somebody who knows what they're doing to monitor it. But again, it's a failure recovery method, so you will be suffering some sort of downtime when a machine goes down. So it's only really FT Server that's failure prevention. It's the only machine that ensures no downtime. 99.999% available. If you go on the Stratus website today, you'll probably see 6 nines, sometimes 7 nines, that's reported on there from them monitoring all the machines that are out there. So because you've got the 2 slices in lockstep with each other, it means that you don't suffer downtime. If slice A fails, and it's in the middle of writing data to a historian or something, because that bottom slice is just powering on through, riding out that failure, you don't lose what we call in-flight data. So that data isn't corrupt or lost, potentially like you get in the other solutions. And because it sees itself as logically one single server, you don't need multiple copies of the application. So when you look at cost comparisons and things, especially when you factor in the people that you need to manage the other solutions, it often works out better. So definitely something to consider. Next we'll look at network segmentation. So here we've got a traditional flat network. Big no-no. Everything can talk to itself, well, can talk to each other, I should say. If we use another analogy, if you imagine an open plan office, somebody walks through the door, shouts a message, everybody in that open plan office can hear it. Everybody's got the ability to respond to it. So that's where the nasty gossip starts. So yeah, not something that we'd recommend. And what we can do to try and sort of mitigate these risks, because it's very difficult to implement more security into these systems, is to introduce zones and conduits. So zones can be implemented in 2 different types of ways. So you can use a physical zone, so every network device in that zone has the ability to talk to route traffic to other devices within that zone that's physically segmented, or there's the logical way of doing it so that you introduce VLANs to be able to do it, which is a bit more flexible. So if we look at a physical segregation, you can see there we've split it down into core production zone, packaging zone, DMZ, with a layer 3 device in between. And what I would suggest is that before you sort of go on this journey is to have a think about how you'd segregate them. Try and group your devices by common security goals. So say for instance you've got some legacy devices, it might be machines on XP or something, there aren't the latest update patches for them. So I'm guessing that they're high security. So try and group those together, that's the best way of doing it. So we've got the layer 3 device in the middle, and then you've got these lines branching out into each zone, and that's going to handle the routing of the traffic. These lines are essentially our conduits, so they're like a secure tunnel between each zone. So if something from the packaging zone wants to talk to the core production zone, it's got to negotiate through this layer 3 switch, this layer 3 device in the middle. So it could be that you've got a device in the packaging zone and it wants to go and get it wants to communicate with a reporting server in the DMZ. Could be like a Wonderware OEE stuff. So it wants to go and communicate with this reporting server. So what we could do is we could put conduits in there to say we will only allow HTTPS traffic between those two zones, because that's the only reason why there'd be a communication path. And that will limit what can and can't get through. So it means that you're going to get what you want through, but limit everything else. So a really, really secure way of doing it. But like I say, you're bound by physical boundaries. So if we were to look at a logical way of doing it, we're now introducing VLANs. So you can see there we've now got different devices that can host traffic in different zones. So we're not bound by these or constrained by these physical locations, and it makes it a lot more flexible if we want to add new zones in the future, if you've got the ports available, of course. So much more flexible, and just as secure. There is a myth really that, you know, how can doing it this way be as secure as having it physically, you know, boarded off? But I can assure you it's just as secure, and it gives you that flexibility. So whilst we're talking about conduits, what we can also do is look at deep packet inspection firewalls. So there are devices from Hirschman called Tofino, and they are specifically designed for the OT space. So what we do is, if we take that same SCADA architecture that we looked at earlier on, and we replace some of these firewalls with Tofino devices. So we're still going to have our layer 3 device, our layer 3 firewall, as our perimeter defense. But what we're going to do is introduce each sort of island of automation a Tofino device. So it could be that you've got those XP devices that I talked about before, something that's, you know, needs high levels of security. This is sort of perfect place to put one of these Tofinos. So, like I say, they're designed for the industrial space. What's kind of cool about them is they're undiscoverable on the network. So whilst you're configuring them, they will pinch an IP address or something downstream from it, so that you can configure it. And when you put it into live mode, it just disappears. It's undiscoverable. And what it'll do is, because it's designed for the OT space, it understands our protocols. So it might be that this is a Modbus network and you only want to allow Modbus traffic through here. So you impose these rules into the device, and it'll enforce them for you. You can use loggers and things to monitor the device, the traffic that was tried to go through that device or tried to go through the network, to monitor what's going on. But yeah, a really secure way of securing your architecture. So then if we look at managing authorization, we're going to go back to the thin manager example again. So what we can do is we can utilize Active Directory, pull that through into Theme Manager, make it really, really easy to use and manage, and then we can look at how we divvy up this content to the users. So in the top there, we've got an operator and his terminal that's running a HMI. So he's only allowed to access the HMI server. So we're going to introduce a badging in system for him. So he's got an RFID badge, like what you might use to enter your building or go through certain doors or something in your office. You badge in using the RFID card, and it will automatically recognise that it's a HMI user and pull that information from the HMI server, and that's all. And then in the bottom example, we've then got a supervisor. So he's got access to the work order server and the admin server. So he's got potentially different applications to the HMI guy. So it could be that he's gone into the core production area and he wants to see some of the OEE figures that we mentioned earlier on. He's going to call, through to the reporting server, whatever it might be. So when he badges in, it logs the other guy out, removes those applications, and pulls through the stuff that's relevant to him. If he then moves to a different area or logs out of the machine, those applications, those bits of content are going to follow him around the factory floor. So a really easy way of managing who has authorization to view what content. This depicts it really. We're going to pull through the Active Directory information, and it's going to be linked to an AD account. And once it's been authenticated, the content can be delivered to the terminal or the user, dependent upon that user's role and responsibility. You can do that with badges, you can do it with biometrics, fingerprint scanners, that kind of thing. So very, very easy to manage. Next, if we look at remote access management, so I guess in the IT world, remote access is something which they've been providing for years and years and years, in a very, very secure way, and they've done that because they adopt stringent processes and policies. So they've just been doing it for a very long time, and in the OT space, OT engineers, they're not as comfortable with it. So it's something that it's probably because we don't adopt the same rigor and apply that to it. So if we look at how you do it before you'd implement changes, you can see it's all in a bit of a mess. Is the shared passwords up there in the top right hand side of the screen, and yeah, it's another big no-no really. So after we've adopted a solution and changed it somewhat, it's a much more structured architecture. So now we've got the ability to manage any connection into the OT network more securely. So we've sort of flipped it on its head. We've now introduced an administrator, so they've got the ability to control, monitor, and audit the connection. So they've now got the control to see who's got access and what devices they've got access to. They can monitor connections whilst they're in progress, and they can audit the security of the architecture. So just sticking with those points: control, monitor, and audit. In terms of control, they can proactively create a password vault for user authentication. They can also impose a manual approval before a remote connection is initiated. In terms of monitoring, effectively they can babysit a session in real time, so they can actively see what is happening whilst the connection is in progress. And if they don't like what they see, guess what? They've got a big red button there. They can kill it. They can terminate that remote connection if they're not comfortable with what's happening there. And the sessions, they can be recorded for auditing purposes, so you can review what has happened in the past to audit the solution. So really, really useful tool. And then we'll move on to ICS network audit. So that's something that we touched on earlier on in the webinar. So guess what? This is something we can do. So if you imagine you've got your IT guy who's looking after your mail server or something, the chances are if something went wrong with that network and he couldn't fix it, if he was going to let somebody through the door to take a look at it, they've got to have the right qualifications. They've got to be certified and have the right approvals in place. Otherwise, he's not going to let them near it. And we don't really adopt that same rigor as in the OT space. So we've got, you know, all sorts of people that have the ability to access and mess around with networks that potentially they shouldn't have. So what we do is we make sure that the people carrying out these audits, we will not come and allow somebody to have access to your networking infrastructure unless they've got the right approvals and qualifications under the belt and the right experiences. So the network audit is what we discussed earlier. It's to assess the lay of the land, try and understand how the network is currently. Are there any flaws? Are there any of that low-hanging fruit that we touched on earlier that you can address right away? And then as part of that, we're going to create a written report for you identifying these changes or these holes that are there at present, and then highlight any changes that, you know, hey guys, it might be good to take a look at implementing this kind of solution, or making these changes, and that's going to make you more secure. So they're available. Please come and speak to us if that's something that you would like to embark upon. And really that takes us to the end of the webinar. If you've got any questions, if you want to email those over to info@solutionspt.com, and we'll take a look at those and answer them for you. But yeah, I'd like to thank you for spending your time watching the webinar with myself and Andy, and I hope you enjoy the rest of your day. Thank you very much.